Figure 117 example shows a vector of 10 Newton on the vertical axis against a vector of 12 Newton on the horizontal axis. Figure 117 example. In the above figure, calculate the resultant of the two vectors. Figure 118 example shows that the vector 12 is on the horizontal axis which started the vector. Then at the end of the vector starts the vertical vector, which is the 10 Newton vector. The resultant R, it will be at the hypotenuse, since it will start from where the both vectors start and end where the two vectors end. Solution. According to the law of Pythagoras, the square root of the hypotenuse is equal to the sum of the squares of the other two sides. The hypotenuse is now r squared is equal to the 10 Newton squared plus the 12 Newton squared. Adding both will give 244. Then the square root crossing over will become the square root of 244, which will give us 15.6. Then looking for the theta, tan theta is equals to 10 over 12 according to the trigonometry, law of trigonometry, which will now give us 0.8333, which is 39 degrees. If we do the tan inverse of 0.8333, it will give us 39.48 or 39 degrees 48 inches. Resultant is now equals to 15.6 Newton, which is at 39 degrees 48 inches to 12 Newton. Example 2. Find the sum of two vectors A and B, where A is 5 meters at an angle of 60 degrees and B is 6 meters at an angle of 130 degrees. Solution. Figure 119a shows an angle of 60 degrees having 5 meters length, and figure 119b shows a vector of 130 degrees at an angle of 130 degrees having a length of 6 meters. Figure 119c now represents the angles on a Cartesian coordinate, and combining the two vectors. The 60 degrees vector first started the vector and now ends at 130 degrees. Then the 130 degrees now ends the vector at 6 meters. Then the resultant will be from where the vector started, which is at 60 degrees Cartesian coordinate, to that of where the vector ends at 6 meters. Then, in law of triangle, we have angles at opposite are equal. So the Cartesian coordinate inside the 130 degrees is 60 degrees. Since the horizontal line is 130 degrees and it is 180 degrees, then we minus 180 from 130, which will give us 30 degrees. Therefore, the angle inside the triangle is 101 degrees. Applying the law of cosine relating C to A, B, and the angle opposite C, we have that C squared is equals to A squared plus B squared minus 2AB cos 110, which is equals to 5 squared is 25 plus C squared is 36 minus 2 times 5 in bracket times 6 closing bracket cos 110, which will now give us 60 plus 20.53. Therefore, c squared is equals to 81.52. Making c the subject of the formula by crossing the square to the other side, we have the square root of 81.52, which will give us 9.02 meters. Angle theta can be calculated by the law of sine as follows: sine theta over b equals to sine 110 over c. Making sine theta the subject of the formula, we have that b over c sine 110. Then we have c over 9.02 times 0.91, which gives us 0.6263. And finding the tan inverse of 0.6263, we now have tan equal to 39 degrees. The magnitude is 9.02, making 39 with A. Resolution of vectors. Resolving of vectors into component vectors can be resolved into horizontal and vertical components as shown below. Resolving a force F in figure 120 resolution of vector, we see that the force F at an angle theta. The vertical axis is force sine theta, while the horizontal axis is force cos theta. Then figure 1.21 example shows a resolution of three vectors in the same Cartesian coordinates f1 and f2. f1 is acting on a theta, on an angle theta, while f2 is acting on angle phi. F sin theta is for the one on the left side, while f cos theta is for the coordinates on the right side. Resolution of force of above figure 121. Resolve the force above force acting on the body into its components. The forces F2, F1 makes angle theta and phi respectively with the horizontal. Hint: if the body in figure 121 is in equilibrium, horizontal component of F2 is equal to F2 cos phi. Horizontal component of F1 is equal to F1 cos theta. Total horizontal component Fx is equal to F2 cos phi minus F1 cos theta. Vertical component of F2 is equal to F2 sin theta. Vertical component of F1 is F1 sin theta. Total vertical component Fy is equal to F2 sin phi plus F1 sin theta minus F3. Example 3. Find the tension in both strings represented below. The strings are carrying 20 Newton body, and the tension in T2 is at an angle of 30 degrees to the horizontal, while the tension of the string of T1 is 45 degrees to the horizontal. The horizontal component of the string T2 is T2 cos that, while the horizontal component of T1 is T1 cos 45.